Hello, and welcome to Tips, Tricks, and Best Practices for Gaining Efficiency in Your Forensic Laboratory, brought to you by Forensic and sponsored by Thermo Fisher Scientific. This is the fourth webinar in the six-part Future Trends in Forensic DNA Technology series. My name is Michelle Taylor, Editor-in-Chief of Forensic, and I will be your moderator throughout. For today's webinar, you can earn 1 hour of continuing education credit. Following the conclusion of the webinar, you will receive an email with information on how to obtain CE credit documentation. We have a great lineup scheduled to present to you today, but before we begin, I'd like to cover just a few logistics. At the end of the presentations, we will hold a Q&A session. To ask a question, click on the Ask a Question tab in the upper right corner of your screen. Please also take note that the right side of the screen features an overview of today's webinar, as well as more information about our speakers. If you have a technical question during today's event, click on the Test Your Connection button on the bottom of the screen. From there, you can access additional webinar support. We also invite you to use the social media widgets beneath the webinar to share with your friends and colleagues. Today, you'll be hearing from David Miller, Forensic Scientist Supervisor at the West Virginia State Police Forensic Laboratory. He has 26 years of experience as a DNA analyst and biological evidence processor. Miller is a member of the West Virginia Sexual Assault Forensic Examination Commission and works closely with the West Virginia Foundation for Rape Information Services to improve collection and testing of sexual assault evidence collection kits. His education includes a BS in biology from West Virginia State College and an MS in forensic science from Marshall University. You will also be hearing from Gareth Steed, Production Application Specialist at Thermo Fisher Scientific. Steed has held this role for the past 8 years. Prior to his work at Thermo Fisher, Steve was a biochemist researcher with Forensic Science Service in the UK, as well as a laboratory analyst with AB Bio in agricultural and food services business. Steve received his Bachelor of Science honors in Forensic Science from England's University of Kent. Thank you for attending the fourth session in the six-part Future Trends in Forensic DNA Technology webinar series. After this webinar, please be sure to check your email for more information on CE credit documentation. We look forward to seeing you on September 10th for the fifth part, Advances in Analysis of Human Remains. And without further ado, I'm going to hand it off to David to get us started.
Good morning, and thank you, Michelle and Thermo Fisher Scientific, for the opportunity and invitation to speak to you today regarding how the West Virginia State Police Forensic Laboratory is using sodium hydroxide extraction and quantifier trio as a Y-screen to improve workflow with regard to sexual assault evidence collection kits. We'll discuss how our small laboratory ended up moving from a body fluid identification to a Y-screening process, and keeping in mind the SWGDAM report released this past June on Y-screening. But first, a little bit about our state and our situation here. West Virginia has a population of a little bit under 2 million, which our laboratory serves. The number of reported sexual assaults in our state is around 1,100 a year, and we have one standardized sexual assault evidence collection kit, which we use statewide. We also distribute that kit to several laboratories in Ohio and in Maryland for use on West Virginia victims, kits that will be coming back to us. And our kit is a pretty standard kit. It contains 2 internal vaginal swabs, 2 external vaginal swabs, anal, oral, additional swab for oral contact. There's a pubic hair combing or pubic area swab envelope in there. We also have various packaging items for clothing, and we also include a toxicology kit with blood and urine collection materials for drug-facilitated sexual assaults. But we have 72 collection facilities in our state, including hospitals, child advocacy centers, and healthcare clinics. One does not have to be a SANE trained nurse in West Virginia to collect a kit. We have SANE trained nurses as well as non-SANE trained individuals collecting kits. So based on that training and experience of those individuals, we do see a wide variety of both quality and quantity of items collected in our kits. To help with that situation, we use our in-house tracking software application not only to track the location of kits, but to also record the quality of the kit collection. We will make comments if an individual says that there was oral contact with her neck, for example, but there were no neck swabs collected. We will provide a quarterly report back to that hospital saying that there's a need for improvement there, and we will also provide that information to our SANE trainers so that it can be used in their trainings. Our laboratory itself is made up of 2 sections with regard to DNA. We have a biology and processing section with 6 full-time forensic scientists, one of which is in training and recently hired. And our biology DNA section has 11 full-time scientists and 3 technicians, a total of 4 who are in training at this point. And you'll recall I just said that we have about 1,100 sexual assaults reported in West Virginia a year. Our sexual assault kits are distributed by the processing section of the laboratory. We custom order them through Searchy and distribute about 600 kits on average a year over the past 8 years while we've been recording this information. And we have received back about 1/3 of those kits year after year repeatedly, even though we've requested repeatedly that all kits which are collected be submitted to our laboratory. This was especially true following our DANI grants and Psyche initiative projects, where we are required to prevent kits from being unsubmitted to our laboratory. So we can see from this chart that we have a problem getting the number of kits that we send out coming back to our laboratory. To be fair, some of them are non-reported sexual assaults, which go to another off-site facility at Marshall University for storage. And we know that some kits are used in training, but we estimate that around 200 kits a year are collected and not submitted to our laboratory. Our laboratory supports the mandated submission of a sexual assault kit. If it's collected, it should be submitted here. This is also supported by our state's Sexual Assault Forensic Examination Committee. So we are in support of a mandatory submission and began several years ago preparing for such a thing to occur. We increased our storage capacity at our lab. We can now house upwards of 3,000 kits if we had to in a newly built evidence storage room. And we began the hiring process of 2 new employees, one in the processing section and another in DNA, to handle the expected increase in caseload that this would bring about. And most importantly, we began validating and looking into the Y-screen process to change our workflow with regard to moving from body fluid identification to a Y-screen. All of that really kicked off in 2019 when the West Virginia State Legislature passed Senate Bill 72, which was the Sexual Assault Victims Bill of Rights. That bill said, among other things, that a victim has the right to have a sexual assault kit tested and preserved by the investigating law enforcement agency. That bill also said that the victim has the right to know the results of those tests, provided that it does not interfere with the investigation. That is the responsibility of the investigating law enforcement officer in the case. That was in 2019. This year in 2020, in March, the West Virginia Legislature passed House Bill 4476, which we call a direct deposit bill, dealing with the direct deposit of sexual assault kits. 4476 says that upon collection, a sexual assault forensic examination kit shall be submitted for testing by the healthcare provider to the West Virginia State Police Forensic Laboratory within 30 days of collection or as soon thereafter as practical. That bill became effective in May the 18th of 2020. Since then, I've been able to look at the increase in the number of kits that we're receiving every month, and I'm able to project that by the end of this year, we will see approximately 400 kits submitted to our laboratory. I expect the increase this year will be about 150 cases. Next year, I expect we'll see a full 200 more cases than our past average. It might be interesting to note here that we are receiving fewer requests this year for sexual assault kits. I don't know if that's the case nationwide, but we have speculated a little bit that this is perhaps due to some fear of going to the hospital in these times. So you can see here we did have an increase, an expected increase in the number of kits that we are having received at our laboratory. I will say that House Bill 4476 had some teeth with it, calling it a misdemeanor crime if anyone willfully neglects to follow this directive. So prior to February of 19, our laboratory was performing body fluid identification on all items submitted in a sexual assault case. Clothing items, swab items in a kit, bedding, whatever was submitted. We tried to limit the items, but for the most part, our case submission policy would allow for multiple items to be submitted, and we would perform that leukomalachite green presumptive test, acid phosphatase presumptive test, an ABA card P30 lateral flow immunoassay for prostate-specific antigen, followed by a Christmas tree stain, and your occasional RSID saliva test. If you're performing those tests, you know that they take time and sample. Time and samples both are consumed in this testing. Notice that top slide in the center, the amount of material that we would take from the swabs for a acid phosphatase test. We'll come back to that in a minute. And here are the amounts of sample that we would take for a P30, and then maybe another cutting for an RSID if it was requested. Our laboratory at the conclusion of that testing would maintain our multiple samples retained for DNA testing. Multiple extractions, quantitations, and amplifications would then be performed in the DNA section on those samples. Just as a note, our DNA section is using QIAGEN EZ1 Advanced XL for extraction of those samples. We did and still do prepare a report of our initial findings in the processing section. I would also say that in cases that were negative, if we had a negative presumptive test or negative confirmatory test, we would keep samples knowing that the DNA testing is more sensitive than our presumptive testing. So if there was an allegation of a contact, we would keep that sample even with a negative presumptive test. So after February of 19, we began doing a sodium hydroxide extraction and quantifiler trio amplification on swab samples in male suspect and female victim sexual assaults. This is what we validated. Let me thank Thermo Fisher and Jarrett for the work they did on that. We've benefited greatly from it, but we are performing the Y screen on 2 swabs per area tested. So I mentioned that our internal and external vaginal swabs, we typically request 2 swabs for every area, every body area that could be collected, and we test those together. We would take 1/10 to 1/8 of each swab and combine that into one Y screen test for that area swabbed. Most swabs in a case are tested. We're typically seeing anywhere from 4 to 12 sets in a usual case, and we are not performing serology unless we're specifically requested to do so. We are a 2 report, 2 extract workflow laboratory, so we are still writing a report on our results. Now that we're doing the Y screen, we find that we are only retaining 1 to 2 items retained for DNA testing, and that's based on the result and the scenario that we're faced with. If there is oral contact to the neck or breast, we will keep those swabs if they're positive for male DNA, as well as preferably an internal vaginal swab if that's the best sample. The YSTR decision is made in the DNA section based on the quantitation values from the full swab extraction. So we're not making a determination in processing about the direction the testing will go. That's made after the full extraction over in the DNA section. A little bit about a sodium hydroxide extraction and what we're calling a dirty extraction. There is no purification of the samples that we're testing, so we are only doing this on swabs that are in sexual assault kits, no clothing items. We didn't validate that. But this test is performed in a Lysis column, which you see there in the lower center. This is just a column with a separation filter and membrane, which breaks with centrifugation, allowing the lysate to flow into an extraction tube. We will put the 2 1/10 to 1/8 swab cuttings in 100 microliters of 1 normal sodium hydroxide and place that onto a thermoshaker set at 80 degrees Celsius for 10 minutes at 700 RPMs. It's a very quick extraction. That DNA is stable in alkaline solution like that, and it is then centrifuged for 2 minutes, separating the substrate from the extract, which is then neutralized with 4 microliters of glacial acetic acid. That is then diluted 1/5 dilution in Te-4 and is ready to amplify with the quantifier Trio. So we are using quantifier Trio on an AB7500 real-time PCR instrument, 96 well plate format, and it will take me about an hour and a half from setup to results. And from setup to results, I mean I've got my extracted DNA from the sodium hydroxide extraction. We're going to set up the amplification and place it on the real-time instrument, and within about an hour and a half, we have results and are ready to collect samples for DNA testing. Typically, I'm assigning 5 to 7 sexual assault kits per analyst per week when we're doing these runs, and we are able to set up, do all the paperwork necessary, and add the samples to our limbs, take our bench notes, cut the samples, get them in tubes, perform that extraction, and we will have a result at the end of about a 2-day period. So if we start on Monday morning, I typically have results in 5 to 7 cases per analyst, and I'm ready to go. We will typically batch 2 to 3 analysts per plate and batch our work in that fashion. The real-time PCR itself is the quantifier has 4 targets, really. It has a small autosomal target of 80 base pairs. These are multi-copy conserved regions of DNA. The large autosomal target is 214 base pairs in size. The haploid Y target is 75 base pairs in length. There's also a internal PCR control, which is a 130 base pair synthetic strand of DNA that's amplified. We rely on this amplification here to be a guide to us as to whether or not we're seeing any inhibition in the sample. So we're routinely checking the IPC to make sure we're not seeing any inhibition in our samples. We have seen some, and I'll show you an example of that in a second. But besides the quant values of those 3 top targets, small, large, and Y targets, we are also able to determine a degradation index due to the size of those small and large autosomal targets, as well as a male to female ratio in the case. And this can give us an idea as to whether or not that sample is going to end up going towards a YSTR analysis or perhaps differential extraction and globofiler. Here I have an example of a multi-component plot. This is fluorescence relative to cycle number, and you should be able to see here that the internal PCR control, which is this red curve, kind of took off at around 27 cycles, crossed the cycle threshold there, and we have an IPC value therefore of 27.2 in this case, which is what we typically see in an uninhibited sample. This particular sample was part of our validation and is a 10% male blood mixed with female blood, so 10%, 10 microliters of male blood and 190 microliters of female blood, and that was diluted 100-fold. And you can see from the result that the small autosomal target, which is the primary target of the assay, quanted at 0.02 nanograms per microliter, and the Y value is approximately a tenth of that, which was what we would expect in a 10-fold dilution, a 10-fold mixture like that. So this is what a typical run looks like. The next 3 slides are real case examples where we have taken approximately 7 samples from a sexual assault kit and performed the screen on. And I'll go over how we are using this information to select the samples that are going forward for DNA testing and what we would have done in the past with a Y screen, with a body fluid identification. So this first case is a negative male DNA case where we received 7 samples. We screened 7 samples. The external vaginal swab, an anal swab, a set of anal swabs. The nurse examiner in this case collected 4 oral swabs, so we divided those into groups of 2 and screened oral swabs 1 and 2 and oral swabs 3 and 4. There was a pubic hair swab, a neck swab, and an unusual sample of inside the ear swab. So in looking at the Y values for this, you can see that there was no male DNA detected in any of these samples. And that's exactly how we would have reported this case in our processing laboratory report. We would say that no male DNA was detected in these samples. with the exception of the inside the ear sample, which we would have reported in this case as inconclusive. Take a look at the IPC value there. The internal PCR control crossed the cycle threshold at 31 cycles. This is a little bit high and can be an indication of inhibited sample. In this particular case, we would have called that inconclusive and sent the sample over for confirmation with a DNA extraction and purification before the trio run. Had we been doing body fluid identification on this case, we would know, based on the scenario, what body parts were indicated as being affected in this case or touched, and we would have kept probably the external vaginal swab sample, an anal, an oral, and perhaps the neck sample to begin testing with. The next case, again with 7 samples, is what we would call a low-level male DNA case. Again, we have an internal vaginal sample, which was 2 swabs, a sample just labeled vaginal, which we don't know if that was the same area collected as the internal vaginal, it's just labeled vaginal. The cervix swabs, a mons pubis swabs, 2 swabs labeled around left nipple, 2 swabs labeled around right nipple ring, and 2 swabs from a belly button ring. In this case, we had relatively low amounts of DNA in all of these samples, lowest of them being the cervical swab, which is usually one of the better swabs. But in this cervix sample, and based on our validation, we would call this one a trace amount of DNA because in our laboratory, we know that anything below 0.0004 nanograms per microliter or 0.4 picograms per microliter, we would not expect routinely to have repeatable results on a full swab extract of this cervical swab sample. Right now, we're still calling them positive. We're just saying it's a trace amount, and we're looking into it a little bit further if we can say that an insufficient amount of male DNA was detected to continue on with testing. Right now, though, this is a trace sample. But you can see from these results that I can now make an educated decision about what is the best sample to send over for DNA testing. I just don't have a weak AP and maybe a negative confirmatory test with body fluid ID. I can look at this and say, okay, the internal vaginal swab sample has the highest quant of male DNA as far as an internal sample goes, but I'm going to select the around the right nipple ring swab as an external body sample that has the best chance of giving a full DNA profile. So in this case, I've very neatly narrowed it down to the 2 best samples that we can send over for testing and have our best expectation for results. Thirdly, we have a case with another 7 samples that gave us pretty nice results. So I've got vaginal vault swabs 1 and 2, 3 and 4, another cervical swab, an external vaginal swab, a pubic area swab, and then anal and oral swabs. Of these, you can see the vaginal vault swabs 3 and 4 gave the highest Y value of 0.2 nanograms per microliter, better than the other 2 swabs of vaginal vault 1 and 2. The cervical swab is positive, but not quite as much as the vaginal vault swabs. And the external vaginal swab is very positive. Now, if this case involves someone who had had prior consensual intercourse, we might then make a decision to test both the internal and external vaginal swab samples. But because in our state the sexual assault is defined by penetration of the vagina, then we are going to usually go with an internal sample if we believe that that sample will give us results. Pubic area and anal swab is also positive, and then there's a nice clean oral sample with no male DNA detected. One of the things that I've been able to do is to take a look at the last 2,000 samples that we've done the Y-screen on and make a comparison of the body cavity and the amount of times that we obtain a result. I've done this for internal and external swabs, and you can see here that the vaginal swabs that we get about 47% of the time are positive. Compare that to cervical, where about 61% of all the cervical swabs that we've tested have been above 0.0005 nanograms per microliter. So above 0.5 picograms per microliter, we're seeing that 61% of our cervical samples. Compare that to the oral, where only 7% of the time we're getting a result that's that positive. With regard to external body swabs, breast have been pretty good at 22%. Neck, over 56% of our samples are positive when they're collected, which is a really great sample. So I can take this information back to our SANE trainers, back to our hospitals, and say, be sure to collect that neck swab. If she says there was oral contact with the neck, get that neck swab. Take that cervical swab. Those are showing to be our best samples. Some of the other things that I'd like to do in the future with this chart would be to add to that the post-assault interval and say, how often are these samples positive when there was a shower? How often are these samples positive from 24 to 48 hours after the assault, 48 to 76, and so forth? Can we say more about when we lose the ability to obtain a DNA result from a sample based on post-assault interval? Can I make any conclusions about whether a SANE trained nurse is doing a better job with quality of collection than a non-SANE trained examiner? That's something else that we can do to try to support the use of SANEs in our state as those who are collecting sexual assault evidence kits. And lastly is a slide where I tried to make a little bit of a comparison between the cost of performing a body fluid identification, which we have on the left, and a Y-screen examination, which I have on the right. Relatively speaking, there's not a great difference in the cost here. The cost savings and the time savings that we're seeing is coming post-processing, where we're able to make a better informed decision about what is the best sample to keep for DNA testing. I do think there is some cost savings. I think we're seeing some time savings because I'm not having to wait for an hour extraction to do a P30, and then if that's negative, selecting another sample to do, or I'm not spending an hour at a microscope looking for sperm in a case where they don't exist. We're going right to the Y screen, learning if that male DNA is present, and then sending the best samples over for DNA testing. So I look forward to some conversation about what we're doing here and how we're doing it. How are you doing it with regard to the SWGDAM report? And with that, I will give this to Garrett, and he can continue the conversation. And I do look forward to some conversation. And thank you for your time.
Thank you for the introduction, and hello everybody. Today I'd like to speak with you about laboratory automation and how that can be used to improve the efficiency of your laboratory's workflow. And in addition, I'd like to speak about the HID Professional Services team, of which I'm a member, and how we're able to partner with your laboratory to help in the adoption of new technology and new automation. So when we think of workflow efficiency and the benefits of it, the first points that most people often think of are the two listed at the top here. So this is an improvement in the amount of time it takes to process a sample, and secondly, the number of samples that your laboratory is able to process. We also need to think of some of the other benefits, for example, precision and accuracy improvements. And this is evidenced in a reduced number of samples that need to be repeated. Again, improving time to result and increasing sample throughput. There are also other benefits, for example, with data management, reduction of cost, as well as optimizing the tasks and tools and resources in your laboratory. For example, making best use of the laboratory analysts that you currently have, the equipment that you currently have, and the space that you have in your laboratory. And thinking then about validation, we often think of validation as one single item, but if we dive down under the surface of a validation, we'll see that there are actually many different components that make up a validation. And this is everything from the initial developing a method and testing it through to what traditionally people think of as validation, which is the wet work, the practical lab work to test the system, analysing the resulting data and preparing reports that are suitable for your regulatory requirements. But then the validation doesn't end there. We also need to think about how can we train your laboratory analysts in this new technology? How can we assess their competency in it? And how can we help you in preparing SOP documents, for example? So there's this whole raft of separate stages that make up a full validation. And the HPS team is experienced in all of this, and we've partnered with multiple labs to deliver some or of these parts of validation. So thinking about process efficiency improvements, one of the first steps that we need to look at is, where is the bottleneck in your workflow? And a bottleneck can occur really anywhere from the initial receipt of a sample right through until where we have the final result and we're able to produce a report on that sample result. And the key here is that we need to identify the bottleneck, but then we need to not just move it, but to actually remove it from the system. For example, there could be a bottleneck in the sample purification step. If we just address that, for example, with adding new or additional automation, then we may just move that bottleneck down to quantification, where the existing systems that the laboratory has in place just can't cope with the extra level of samples that are placed upon it. And so we've just moved the bottleneck to the quantification step. So really the key here is that we need to be looking at the lab's workflow in its entirety. We can't look at each individual part in isolation. We need to consider everything and how we can completely fix the system rather than just tweaking with certain elements of it. And this slide, there are just some examples here of various liquid handling robots on the market that we've had some experience with here in the HPS. These include instruments from Hamilton, from Tecan, and from Beckman. And by no means is this an exhaustive list. We have worked with other instruments and we can support customers that are running different robots to these shown. We are very lucky in the team that we have a lot of experience in-house in working with these multiple instruments. We have good contacts within the robotic companies themselves, so we are very well placed to be able to support you on these instruments shown here, and also a wide range of other instruments. And if we just take a step back and think now, regardless of the technology that you go with, so regardless of whether it's a Hamilton robot, for example, or a Tecan robot, there are definitely core features that you need to be considering regardless of the technology that you select. The first is the ability for barcode tracking. Barcodes are a very simple way of tracking samples and reagents throughout the whole process. It's a way of reducing errors and reducing operator hands-on time. And in the robotic system where everything is logged and recorded, it's a very simple way to be able to show that samples are processed as expected, and that can be demonstrated in the results files that are generated. You also need to consider work lists. So for example, is there a LIMS that you need to integrate with? Considering things such as run parameters. So for example, you may currently be working with samples in tubes, but on switching to automation, it may actually become apparent that it's more appropriate to be working with plates in all or part of the workflow. So it's looking at what you currently have in your workflow, but also what would be most appropriate going forward. And then we need to consider reports and files. And this is almost an extension of work lists. So what do you need the robot and the software to be able to produce for you? For example, you may wish for it to generate not just a LIMS file, but also a file that could be used on a downstream robot, for example, or possibly a plate map file for a Quant Studio 5 or a 3500 instrument. And this is just another benefit of automation, that these files are automatically generated. So it's reducing operator time in generating these files, and it's also ensuring that there are no errors in these files also. And then just thinking then about some of the systems that are on the market at the moment that we have supported and have experience with. So thinking about the beginning of the process, so extraction, beginning with Lysis. So this is frequently a bottleneck in many laboratories because it's a very hands-on process, and typically it is performed manually in the majority of laboratories. And so this photograph here is actually taken from the Hamilton Autolyse robot, which is a very nice solution that is able to fully automate the Lysis protocol. And one of the real benefits here is that not only is this entirely operator hands-off, it means that one operator taking charge of this one instrument can process a full batch of 96 samples themselves. And it's also freeing up their time as well, so that whilst this robot is running, they're able to be in the laboratory or perhaps out in the office kind of doing other tasks that they need. So really it's making the best use of the resources that you have and making the best use of people's time. And then if we then think of the next stage of the process, so this is the actual purification step, so following Lysis. So again, we think here, this photograph is taken from a Hamilton ID Starlet. This is able to process a batch of 96 samples at once. So again, like with the Autolyse, this is one operator able to take care of all these number of samples in one go. And if we're comparing this, for example, to small-scale instruments, so perhaps an Automate Express or an Easy One that work in much smaller numbers, you can really see the benefit that one operator is able to process many full-time number of samples in one run. And this is where this nicely moves on then to just highlighting one of the newest solutions that we have available for extraction, and that's the ID Nimbus Presto instrument. And this actually achieves sample extraction through a different approach to that may be achieved, for example, with a Hamilton ID Starlet or a TCAN Evo. And rather than pipette transferring, we're actually using magnetic rods to achieve particle transfer. So here we have a magnetic rod that is covered in a disposable plastic cover that the magnetic particles bind to, and they are then moved between the various reagent containers. So for example, they can be moved to the reagents for binding, and then subsequently to the reagents necessary for the multiple wash steps and the final elution step. And so here, this is an actual picture of the instrument. So this is one of our newest solutions, which we launched at the end of 2019. So what we've done here is we've taken two instruments that already existed on the market. So on the left, there we have the Kingfisher Presto, and on the right is the Hamilton ID Nimbus. So we've integrated a Kingfisher Presto into a Hamilton robot. And yeah, there you go. We just have some parts of it highlighted here. So on the left, which is where the Kingfisher Presto is located, this is where the actual core of the extraction takes place. And then on the right-hand side, which is the Hamilton deck, this, for example, is where you would load your samples, processing plates, pipette tips, and also containers of the prep filer reagents. And at the very bottom right there, you'll see that we've highlighted the barcode scanner. So the robot includes an integrated barcode scanner, coming back to what I was mentioning earlier, just about the importance of barcode scanning in automation, and how then this instrument is able to ensure accurate and reliable sample tracking. And this is just a nice schematic of the instrument, just kind of showing it from above, so we can quite clearly see on the left-hand side where we have the Kingfisher Presto, which is the region where the extraction is taking place. And then in the middle, then we have the processing area, which is where reagents are added to plates, where the sample is transferred into a processing plate at the beginning of a method, for example. And then on the far right, then we have a waste container, and next to that, the region where you would load your samples. And so, like I said, this is a solution that is currently available. It launched at the end of last year. This is an extraction-only instrument, and the real benefit of this is the speed in which it can process. So it can process a batch of 96 samples, and it takes less than an hour for those 96 samples. So it's in the region of 50 minutes it takes to process a full batch of 96 samples, which if you compare it to some of the existing automation on the market, it's much faster, and obviously considerably faster than if you're thinking about manual processing. And just to highlight some kind of recent development work that's going on with the instrument. So as I said, the instrument has launched, but we continue to develop and create new solutions for it based on customer demand. So the latest project is that we are working with the prep filer BTA kit. So this is the DNA extraction kit that has been optimized for working with bone, teeth, and adhesive samples. So in addition to actually having a new protocol that can be installed on the Nimbus Presto robot, this will be supported also by the launch of a new kit, which will be the automated prep filer BTA kit. And this will have all the reagents necessary for BTA extraction, and they will be provided in large volume bottles suitable for automation. So this is currently being validated at the moment. So it's being co-developed between ourselves at Thermo Fisher and by Hamilton Robotics, and it's currently in our validation phase at the moment. And based on the customers who we've spoken to, so as well as kind of testing this to ensure that it works well for the core bone, teeth and adhesive samples, we will also be looking at, for example, touch DNA samples, because we know that some customers do like to use this BTA kit for a wider range of sample types. Perhaps they prefer one kit for all sample types. So, as I said, this is currently in development, and we're hoping to launch this in October of this year. So in a couple more months, this will be fully available as a solution. So we will have the instrument supporting regular PrepFiler, and then secondly, the PrepFiler BTA. So that was thinking about DNA extraction. If we kind of move on to the next stage in the process, and automating the quantification step, I think one of the real key features about quantification and automation for quantification, and one of the real benefits for that, is if we think about standard curves. So a robot, you can guarantee, will always pipette in a consistent way repeatedly. So whether it's the first run of the day, whether it's your 100th run overall, whether it's the 1000th run that a robot has ever performed, it will pipette consistently. And we don't see differences. So for example, you may see slight differences in pipetting by a single analyst, and more noticeable differences in pipetting between different analysts. But with a robot, it will run consistently. And so that is then removing any kind of worry that there may be about whether a standard curve would pass or not. So the robot is able to create standards automatically for you. If you already have some existing standards, perhaps they've been prepared on a previous run by the robot, then those can be used instead. And also now that we have the ability to support a virtual standard curve, it truly means that we can process a batch of 96 samples on one plate, so without needing to leave any additional space to allow for positioning of standards as we traditionally would have needed to. And then if we think of the last step in the pre-PCR workflow, which is the PCR setup and normalization, again, this is where we see a huge time saver compared to manual processing. So the software is able to automatically analyze a quantification results file, perhaps a Quantrio file from a QuantStudio 5. It's able to analyze that and then to determine how each sample needs to be diluted to achieve a particular target input for PCR. And it's very easy to set variable targets per sample within the software. So perhaps one sample is having a recommended 1 nanogram input, but for another sample you wish to have a slightly lower or perhaps a slightly higher input. So that's all very easily entered into the software, and in the background then the required calculations are performed automatically. You can decide what to do with each sample very much on a sample by sample basis, so not only input level, but you can easily choose, for example, to skip a particular sample based on quality criteria that you've defined in the software. And also, just kind of a final note that I should mention then is regarding direct amplification. So this is also another technology that we're able to automate, and it's something that we have solutions already on the market for, and something that we have a lot of experience of working with. So whether that's working with blood or saliva as a sample type, whether the substrate is FTA cards or perhaps Copan nucleic cards, or whether you're working with swabs, then that's all entirely possible through automation. The example shown in the photo on the bottom right here, this is a Hamilton Easy Punch robot, which is able to work with sample cards. There's an imaging system that's able to take photos of the cards, it's able to determine the optimum position to take a punch, and then automatically punch that into a PCR plate. And this technology is able to work with all of our direct amplification chemistry kits. So, for example, Global Fowler Express or perhaps Verifowler Express, that's also supported as well. And kind of as a final note, I just kind of wanted to talk about the HID Professional Services team, of which I'm a member of, and really how we can work with you as an implementation and validation partner, not only within automation, but also within regular sample processing as well, if that's what your laboratory needs. So as I've said, we're able to work well with our internal team and also robotic vendors and their applications team. So we're able to create methods for you, identify what we would consider to be good solutions for you based on your current workflow and what your workflow requirements in the future would be. And then kind of once we have these instruments and these protocols in place, then we can work, for example, on performing verifications or validations, or a performance check, which would be used where there are multiple instruments, multiple new instruments, and we're kind of comparing the performance of all the instruments together to ensure that they're all performing to a similar standard, as well as also then, as I mentioned before, performing training, looking at things like competency, SOP documents as well, so everything that's necessary. And I'm just going to round off the presentation just by sharing some contact details here. So there's obviously my email address there, and two of my colleagues, Jarrett and Scott, who are both based in North America. So that's kind of really highlighting that we very much have a global reach. So we kind of cover every territory globally. We have robotic experts available within all the regions, so we're definitely able to support you, and really we just need to know how we can work with you, how we can partner with you, and what we can do to help you. And with that, I'd like to say thank you for your attention, and please let me know if you have any questions. Thank you.